So let's give you another chain rule. Chain
Another
rule,
one.
again. Right, because what we did was a function of two variables, and then each of the x and y was a function of one variable.
So now we need 3.
So what if we thought about f was a function of x and y, and x was a function of two variables, and y was a function also of two variables.
Well then.
Okay?
At least they're the same variables.
Yeah, at least they're the same variables. If they're different variables, everything gets really weird. Okay? So, let me see. I really would like to know about... Wait, I gave something away.
It's fine, we probably didn't even know, so keep going. I'm being honest.
Okay, so I'm doing partials now, right?
Yeah.
And what am I trying to do partials of f with respect to?
U and V.
U and v, right? The ultimate independent variables, because really, those are the two independent variables. X and y are dependent, and then f is also dependent.
Ultra dependent.
Yeah. So, I should be trying to calculate these two.
Codependent.
Partials of partials.
Partials of partials, right?
Okay.
Okay, so let me think. I better go over here and put my green thinking marker on.
Well, wouldn't you just...
I want to think about change in f, right?
Uh-huh.
So what's the change in f?
The slopes of X and
Yeah, it's
Times
going to
the-
be fx change in x
Y.
plus
F Y. Change in Y.
fy change in y.
That should be approximately equal to then, right?
Definitely. Thank you. Okay, now which change am I going for?
You're doing U first.
Let me do u first. Okay, so
X.
what's the change in x in terms of
dx with respect to U,
partial of x with respect to u,
and then the change in U.
change in u, right?
Okay.
You guys see that?
So I pick mu. Doesn't make sense.
Right?
Uh-huh.
Okay. And then fy
Times the partial of Y with respect to U times the change in U.
you guys see that?
Yeah,
Yeah, what about the v, right?
That
Well-
I've lied a little bit because really the change in x, right, this piece,
Oh, is
should be the partial of f with partial of x with respect to u times the change in u plus the partial of x with respect to v times the change in v, right?
Oh, so you wouldn't have like.
So
two
what am I
separate
assuming about the
equations?
change in v?
That
It's affected by the
Zero.
change in U.
I'm assuming it's 0 because I'm assuming I'm only going to fiddle with the u's for now. You guys see that?
Can't you do that though?
Yeah.
For- okay.
Yeah, so I took this piece, I zeroed it out because I'm only going to change in the u direction.
Yeah, and we'll do the same thing for when we do the V's, but with U's.
Ah, so remember the change in y also has two terms, and I'm only fiddling with the u piece in y too. So I have exactly this written down with y's, and I'm still zeroing out the change in v piece. So ultimately here I end up with what? So what's the partial of f with respect to u?
partial of f with respect to x times partial of x with respect to u
And the change in U.
du.
Where'd the change in u go?
Oh yeah, those cancel out.
you divided.
Yeah, so to get from this thing, right,
Okay,
to over there, I'm going to divide by change in u,
okay.
right?
And turn it into
And then I'm going to take a
Calculus
limit,
form.
right?
Because this is Jonas's word cancel out thing, so.
Yeah, so then I've got change in f divided by, oh, sorry,
The partial.
partial of f
with
with respect to
Y.
y times,
The partial of Y with respect to.
okay.
So then we just switch those on.
Yeah, and then on the next one I'm going to do exactly the same thing but with v's instead of u's, right?
Uh-huh.
So So I've got partial of f with respect to x times the partial of x with respect to v plus the partial of f with respect to y times the partial of y with respect to v. Cool? Same justification, right? Cool? Check. Your book gives you a kind of a neat tool for this. You want to see the diagram tool?
Sure.
Okay, so the diagram tool, which we should do in a different color.
She's gone for like half an hour.
Okay, so the diagram tool is you take F, right? The thing you're talking about. And then you diagram out, okay, F depends on X and Y, right?
But X and Y depend.
X and Y depend on U and V. X depends on both, and Y depends on both. Okay, and then down each thing you write the appropriate derivative. So on this leg, I'm going to write the partial of f with respect to y.
Oh, okay.
And then here I'm going to write partial of
That's nice.
what?
Y with respect to v.
Partial y with respect to v. This guy's going to get partial
X with respect to v.
x with respect to v. That one's going to be partial y with respect to u. This guy will be partial
X with respect to
x with respect to u, and this guy will be partial f with respect to x, right?
So it's all the pathways added together.
Yeah. So if I want to figure out what f's derivative in terms of u is, I start at f, and I got to take all the possible paths to u. So in this case, there's two, right? There's this one and that one. And I just multiply the pieces together along those two paths. So I've got partial of f with respect to y times the partial of y with respect to u. That's this guy. And I add that to the other path, partial of f with respect to x, partial of x with respect to u. And then to do the other one, right, to do f with respect to v, you take all the pathways down that way. Cool?
That's cool.
This diagram will make, today was when I learned this diagram. It's very cool.
And
It
I
makes your
imagine-
life hella easier when you have like 3 or 4 layers of dependence
I was
because you
going
can
to say
just
we
freaking chase
could
it down.
intuitively go further.
Yeah. Cool?